Today, I am going to discuss Lavoisier and Laplace's law. Let us kick off with identities of scientists Lavoisier and Laplace. Lavoisier. French chemist Antoine Lavoisier. And Laplace, French mathematician. And astronomer. Pierre-Simon Laplace. Put forward Lavoisier and Laplace's law in the year 1780, which is known as Lavoisier and Laplace's law. Now, let us start with some examples. Lavoisier and Laplace's law. A reaction of copper and oxygen. Here, half mole oxygen. Half mole oxygen means 16 gram oxygen. Now, when this reaction is sparked, then copper reacts with oxygen to form solid copper oxide. That is, 1 mole copper reacts with half mole oxygen to form 1 mole copper oxide. Here, new bond is formed between copper and oxygen. That is why, with the formation of copper oxide, the reaction releases 157 kilojoule heat. That is, heat change minus 157 kilojoule. It means this reaction releases 157 kilojoule heat, which is represented by minus 157 kilojoule. On the contrary, when this solid copper oxide is heated, then again solid copper and half mole oxygen gas are formed. Here, this symbol means this reaction is heated. In this case, the bond between copper and oxygen gets broken to form solid copper and oxygen gas. To break this bond, it needs some amount of heat, which is 157 kilojoule. That is, this 157 kilojoule heat is applied here. That is, heat change is plus 157 kilojoule. Simply we can write here heat change is plus 157 kilojoule. Here heat change is minus 157 kilojoule. This is a kind of exothermic reaction. This is endothermic reaction. Lavoisier and Laplace's law says that for any chemical reaction, heat change for any chemical reaction will be equal to the heat change for the reverse reaction. But opposite in sign. This is Lavoisier and Laplace's law. Heat change for any chemical reaction will be equal to the heat change for reverse reaction, but opposite in sign. Another example. Carbon is treated with oxygen gas. The reaction is sparked. Then 1 mole carbon reacts with 1 mole oxygen to form 1 mole carbon dioxide gas. At the time, heat change minus 94.3 kilojoule. This amount of heat is produced from this process, a kind of exothermic reaction. But when carbon dioxide gas is heated again to form carbon and oxygen gas, then it requires some amount of heat, which is 94.3 kilojoule. That is, this process releases 94.3 kilojoule heat, but the reversed process absorbs 94.3 kilojoule heat. That is, heat change for any reaction will be equal to the heat change for reverse reaction, but opposite in sign. Lavoisier and Laplace's law. Another reaction. Solid sulfur is treated with oxygen gas. Then sulfur dioxide gas is formed. At the time, heat change is minus 296.9 kilojoule. It means this process releases 296.9 kilojoule heat. But when the reaction is reversed, then it requires some amount of heat to form solid sulfur and oxygen gas. This heat is plus 296.9 kilojoule. That is, here this amount of heat is released, but for the reverse process, same amount of heat is absorbed. Numerical values are same, but opposite in sign. Lavoisier and Laplace's law. Heat change for any chemical reaction will be equal to the heat change for the reverse reaction, but opposite in sign. Lavoisier and Laplace's law. Thanks for watching.